65 million years ago, a single day changed the course of life on Earth forever. A colossal asteroid, larger than Mount Everest, hurtled through space at unimaginable speeds. Its destination? Our planet. This is the story of the Chicxulub impact, the event that wiped out the dinosaurs and reshaped the world as we know it. The asteroid, estimated to be about 10 kilometers, 6 miles wide, was traveling at a staggering speed of 20 kilometers per second, 12 miles per second. When it entered Earth's atmosphere, it compressed the air in front of it, heating up to temperatures hotter than the surface of the sun. The moment of impact was catastrophic. The asteroid struck what is now the Yucatan Peninsula in Mexico, releasing energy equivalent to billions of atomic bombs. The collision created a crater over 150 kilometers, 93 miles, wide, and 20 kilometers, 12 miles, deep. The shock waves alone would have been felt across the globe. The immediate effects were devastating. The impact triggered massive firestorms, sent towering tsunamis across the oceans, and launched billions of tons of debris into the atmosphere. The heat was so intense that it ignited wildfires thousands of kilometers away. But the worst was yet to come. The debris thrown into the atmosphere blocked sunlight for months, maybe even years. Without sunlight, plants couldn't photosynthesize, and the food chain collapsed. Temperatures plummeted, creating a nuclear winter effect. Over 75% of all species on Earth, including the dinosaurs, were wiped out. On June 30th, 1908, in the remote forests of Siberia, an explosion unlike anything the modern world had ever seen shook the Earth. It was 1,000 times more powerful than the atomic bomb dropped on Hiroshima, yet it left no crater. This is the story of the Tunguska event, one of the greatest cosmic mysteries of the 20th century. At around 7:17 a.m., a massive fireball streaked across the sky, visible for hundreds of kilometers. Witnesses described it as brighter than the sun, followed by a deafening roar and shock waves that knocked people off their feet. The explosion flattened 2,000 square kilometers, 770 square miles, of forest, an area the size of a major city. When scientists finally reached the remote site years later, they were stunned. Millions of trees were flattened in a radial pattern, all pointing away from the epicenter. But strangely, there was no crater. Instead, the ground was scorched and covered in tiny glassy spheres, evidence of an immense heat blast. Scientists believe the Tunguska event was caused by a meteoroid or comet fragment, about 50 to 100 meters wide. Unlike most impacts, this object exploded in the atmosphere, 5 to 10 kilometers, 3 to 6 miles, above the ground. The heat and pressure from the blast were enough to flatten forests, but left no crater. For decades, the Tunguska event puzzled scientists. Was it a comet, a meteoroid, or something else entirely? Some even speculated about black holes or alien spacecraft. But modern research points to an airburst explosion, a rare but natural phenomenon caused by a cosmic object disintegrating in the atmosphere. Today, the Tunguska region has largely recovered, but the event serves as a stark reminder of the dangers lurking in space. It has inspired efforts to track near-Earth objects and protect our planet from future impacts. After all, if something like Tunguska happened over a populated area, the consequences would be catastrophic. In the vast desert of Arizona lies a massive scar on the Earth's surface. a reminder of a violent cosmic collision. This is the Barringer crater, also known as Meteor Crater, one of the best preserved impact sites on our planet. Today, we'll explore its origins, its discovery, and what it teaches us about the power of meteor impacts. About 50,000 years ago, a nickel-iron meteorite, roughly 50 meters, 160 feet, in diameter, hurtled toward Earth at speeds of over 12 kilometers per second, 7.5 miles per second. When it struck the Arizona desert, it released energy equivalent to 10 megatons of TNT, hundreds of times more powerful than the atomic bomb dropped on Hiroshima. The impact created a crater 1.2 kilometers, 0.75 miles, wide and 170 meters, 560 feet, deep. The force of the explosion vaporized the meteorite and ejected millions of tons of rock and debris, scattering it across the landscape. The heat was so intense that it melted the surrounding rock, creating unique minerals found only at impact sites. For centuries, the crater was known to Native Americans, but it wasn't until the late 19th century that scientists began to study it. Initially, many thought it was a volcanic formation. But in 1903, mining engineer Daniel Barringer proposed a radical idea. The crater was caused by a meteorite impact. His theory was met with skepticism, but he spent decades gathering evidence to prove it. Today, the Barringer crater is a treasure trove for scientists. It's one of the first impact sites to be definitively linked to a meteorite, and it has helped us understand the processes behind such collisions. The crater's well-preserved state makes it a natural laboratory for studying impact mechanics, geology, and even planetary defense. The Barringer crater isn't just a scientific curiosity, it's a window into the cosmos. It reminds us that Earth is not isolated from the rest of the universe. Meteor impacts have shaped our planet's history, from the extinction of the dinosaurs to the creation of the very minerals we use today. The Barringer crater stands as a testament to the incredible forces that shape our world. It's a place where science, history, and the cosmos collide. A reminder of our planet's dynamic past and the mysteries that still await discovery.